Objectives. After the completion of this module, you will thoroughly understand the following.
What is a check dam? Benefits of check dam. Suitable location for constructing check dam. Main parts and operating method of check dam. Marking procedure for the construction of check dam. Construction procedure for check dam. Precautionary measures to be taken while constructing check dam. Restoring check dam.
Introduction. When it rains, the runoff water flows from upland areas to lowland areas. The runoff water takes away the upper layer of fertile soil along with it. Formation of 1-inch upper layer fertile soil would require hundreds of years. Hence, protecting such fertile soil is very much needed. The rain runoff passes through gullies, streams, not only leads to breaches to the bunds of the gullies and streams, but also widens the width of the stream. The velocity of rainwater runoff breaches stream bunds. It is very important to protect streams and walls from erosion due to the velocity of runoff water. A check dam is constructed to stop runoff water to absorb the water into the soil to increase groundwater levels. A cement construction across the streams and gullies is called check dam. This construction stores water and excess water flows on top of apron without eroding the soil. Generally, check dam is constructed where the walls of streams are strong and without curvatures. Benefits of check dam. Now let us know the benefits of check dam. Check dam helps to increase groundwater levels by absorbing runoff water. Water levels in open wells nearby areas will increase. Due to increase of water levels in open wells and bore wells, cultivating area will increase. Check dam decreases the velocity of runoff water in streams. Check dam protects the walls of streams from erosion due to flow velocity. Suitable location. Check dam is constructed across the streams which have lesser width. Check dam is constructed where side walls of streams are strong. If check dam is constructed on a weak side walls, check dam may get damaged due to velocity of runoff water. Check dam is constructed at streams which do not have curvatures to some distance. Velocity of runoff water at curvatures is very high and check dam may get damaged. Check dam is constructed at the streams which have at least 1.75 meters depth. This means check dam's capacity to store water will be more than 1.75 meters. Check dam is constructed where slope of water catchment area is 1 to 2%. If check dam is constructed at places with slope percentage of more than 1 to 2%, check dam may collapse due to the velocity of runoff water. Main parts and operating method of check dam. Check dam looks as shown on the screen. Body wall. A stone wall or a cement concrete wall is constructed across the water flow to store water and to reduce the velocity of runoff water. Upstream side cutoff wall. A structure constructed with CC 1:4:8 concrete mixture and across the stream with 0.30 meters width and 0.90 meter depth. Body wall foundation. A structure constructed with CC 1:4:8 concrete mixture contiguous to upstream side cutoff wall under the body wall with 0.30 meters thickness. Core walls. A structure constructed on both sides of body wall with 0.60 meters width and from bottom of the stream to full height of the stream, that is from top level of body wall FTL to height of 0.90 meters. Guide walls. A structure constructed at the bottom of body wall to prevent erosion in the streams due to velocity of runoff water. From core wall adjacent to solid apron with a width of 0.60 meters at the stream up to a height of core wall at 0.90 at one end, at the other end is called guide wall. Solid apron. A structure constructed with 1:3:6 concrete mixture contiguous to the body wall with 1.50 meters width and thickness to reduce the velocity of waterfall from top of the body wall. Downstream side cutoff wall. A concrete construction with 1:4:8 structure constructed adjacent to solid apron with 0.30 meters width and 1.20 meters depth. A groove is excavated under solid apron to prevent water leakage and to protect the construction. Cushion wall. Concrete wall constructed along solid apron on top of downstream side cutoff wall with 0.30 meters width and 0.30 meters height. Talus. Concrete construction with 2 meters width and 225 millimeter to 300 millimeter thickness between cushion wall and toe wall. Toe wall. Cement wall or a cement stone wall constructed on three sides with 0.60 meters width to prevent talus. Working procedure. During raining, the run of water in streams reaches to the bottom of the body wall. Water is stored between side walls which are on both sides of the body wall. Body wall. Body wall releases the excess water very easily. Guide walls. These walls prevent soil on the walls from sliding off due to the velocity of water and protect the cement construction from widening of the stream. Solid apron. This is a place where the excess water falls from the outlet. Cushion wall. This wall reduces the velocity of water which flows on solid apron. Talus. This is a raw stone construction where run of water from cushion wall falls. Toe wall. This is a construction which takes the weight of stones of talus. Tools, implements, items and machinery required for the construction of check dam. Implements: tape, thread, lime powder. Tools: spades, crowbars, cane baskets. Items: sand, cement, gravel. Machinery: concrete mixture. Method of marking for the construction of check dam. First, establish water catchment area based on Survey of India's topo sheet map for constructing check dam. This is also referred to as a catchment area. The length of body wall should be established based on the catchment area, and height of body wall should be established based on height of the bunds which are on both sides of the stream. In the same way, based on the catchment area, depth of upstream cutoff wall H1, depth of downstream cutoff wall H2 and length of solid apron L1 are established. Measurements vary based on the catchment area. First, let us know marking procedure for the construction of check dam. First, mark at one edge of stream and mark it as A1 and fix a wooden pole. At A1, keep one edge of carpenter level parallel to flow direction and pull a thread along the second edge. Mark the length L of body wall on it. Fix a wooden pole here and mark it as A2. From A1, fix a wooden pole at a distance of 0.30 meters at the lower side to flow direction and mark it as B1. Likewise, A2 at a distance of 0.3 meters at the lower side to flow direction, fix a wooden pole and mark it as B2.
Join A1, A2 with a thread. Join A1, B1 with a thread. Join A2, B2 with a thread. Join B1, B2 with a thread. Draw a line with lime powder on the thread that tied A1, A2 wooden poles. Draw a line with lime powder on the thread that tied A1, B1 wooden poles. Draw a line with lime powder on the thread that tied A2, B2 wooden poles. Draw a line with lime powder on the thread that tied B1, B2 wooden poles. The center portion of A1, A2, B1, B2 shows upstream side cutoff wall.
From B1, at a distance of 0.6 meters at the lower side to flow direction, fix a wooden pole and mark it as B3. From B2, at a distance of 0.6 meters at the lower side to flow direction, fix a wooden pole and mark it as B4.
Join B1, B3 with a thread. Join B2, B4 with a thread. Join B3, B4 with a thread. Draw a line with lime powder on the thread that tied B1, B3 wooden poles. Draw a line with lime powder on the thread that tied B2, B4 wooden poles. Draw a line with lime powder on the thread that tied B3, B4 wooden poles.
B1, B2, B3, B4 ల మధ్య భాగం బాడీ వాల్ పై వెడల్పును సూచిస్తుంది.
When looking from flow direction from left side of B1 at a distance of 3 meters, fix a wooden pole and mark it as B5. When looking from flow direction from right side of B2 at a distance of 3 meters, fix a wooden pole and mark it as B6.
Likewise, from left side of B3 at a distance of 3 meters, fix a wooden pole and mark it as B7. Likewise, from right side of B4 to a distance of 3 meters, fix a wooden pole and mark it as B8. Keep one edge of carpenter level at B1 and pull a thread on B1, B2 along the second edge. Mark the bottom width of the body wall and fix a wooden pole and mark it as C1. Keep one edge of carpenter level at B2 and pull a thread on B1, B2 along with the second edge. Mark the bottom width of the body wall and fix a wooden pole and mark it as C2. Join B3, C1 with a thread. Join B4, C2 with a thread. Draw a line with lime powder on the thread that tied B3, C1 wooden poles. Draw a line with lime powder on the thread that tied B4, C2 wooden poles. From C1, as per the design measurements, mark the length of solid apron L1 and fix a wooden pole and mark it as D1. From D1, at a distance of 0.30 meters, fix a wooden pole and mark it as E1. From E1, at a distance of 2 meters, fix a wooden pole and mark it as F1. From F1, at a distance of 0.60 meters, fix a wooden pole and mark it as G1. From C2, at a distance of L1, fix a wooden pole and mark it as D2. From D2, at a distance of 0.30 meters, fix a wooden pole and mark it as E2. From E2, at a distance of 2 meters, fix a wooden pole and mark it as F2. From F2, at a distance of 0.60 meters, fix a wooden pole and mark it as G2. Join C1, D1, E1, F1, G1 with a thread. Join C2, D2, E2, F2, G2 with a thread. Join C1, C2 with a thread. Join D1, D2 with a thread. Join E1, E2 with a thread. Join F1, F2 with a thread. Draw a line with lime powder on the thread that tied C1, D1, E1, F1, G1 wooden poles. Draw a line with lime powder on the thread that tied C2, D2, E2, F2, G2 wooden poles. Draw a line with lime powder on the thread that tied C1, C2 wooden poles. Draw a line with lime powder on the thread that tied D1, D2 wooden poles. Draw a line with lime powder on the thread that tied E1, E2 wooden poles. Draw a line with lime powder on the thread that tied F1, F2 wooden poles. The center portion of C1, C2, D2, D1 shows solid apron. The center portion of D1, D2, E2, E1, which is 0.30 meters length, shows downstream side cutoff wall. The center portion of E1, E2, F1, F2, which is 2 meters length, shows loose apron. Now, from B3 at a distance of 0.60 meters, fix a wooden pole and mark it as B. On the right side of B4 at a distance of 0.60 meters, fix a wooden pole and mark it as B10. On the left side of D1 at a distance of 0.60 meters, fix a wooden pole and mark it as D3. On the right side of D2 at a distance of 0.60 meters, fix a wooden pole and mark it as D4. On the left side of G1 at a distance of 0.60 meters, fix a wooden pole and mark it as G3. On the right side of G2 at a distance of 0.60 meters, fix a wooden pole and mark it as G4. Join B1, B5 with a thread. Join B3, B9 with a thread. Join B9, B7 with a thread. Join B7, B5 with a thread. Join B2, B6 with a thread. Join B4, B10 with a thread. Join B10, B8 with a thread. Join B8, B6 with a thread. Join D1, D3 with a thread. Join D2, D4 with a thread. Join B9, D3, G3 with a thread. Join B10, D4, G4. Join G4, G2, G1, G3 with. Draw a line with lime powder on the thread that tied B1, B5 wooden poles. Draw a line with lime powder on the thread that tied B3, B9 wooden poles. Draw a line with lime powder on the thread that tied B9, B7 wooden poles. Draw a line with lime powder on the thread that tied B7, B5 wooden poles. Draw a line with lime powder on the thread that tied B2, B6 wooden poles. Draw a line with lime powder on the thread that tied B4, B10 wooden poles. Draw a line with lime powder on the thread that tied B10, B8 wooden poles. Draw a line with lime powder on the thread that tied B8, B6 wooden poles. Draw a line with lime powder on the thread that tied D1, D3 wooden poles. Draw a line with lime powder on the thread that tied D2, D4 wooden poles. Draw a line with lime powder on the thread that tied B9, D3, G3 wooden poles. Draw a line with lime powder on the thread that tied B10, D4, G4 wooden poles. Draw a line with lime powder on the thread that tied G4, G2, G1, G3 wooden poles. The center portion of A1, A2, B1, B2 shows upstream side cutoff wall. The center portion of B1, B3, B5, B7 and B2, B4, B8, B6 shows 3-meter length core wall. The center portion of B1, B2, C1, C2 shows bottom width of the body wall. The center portion of C1, C2, D2, D1 shows solid apron. The center portion of D1, D2, E2, E1 shows 0.30 meters length downstream side cutoff wall. The center portion of E1, E2, F2, F1 shows 2-meter length loose apron. The center portion of F1, F2, G2, G1 shows 0.60 meters length toe wall. CC 1:4:8 concrete mixture. Meaning of CC 1:4:8 concrete mixture. 1 unit of cement, 4 units of sand, 8 units of 40 mm gravel, 8 units of 40 mm gravel means 0.92 cubic meter volume of gravel. 4 units of sand means 0.46 cubic meters volume of sand. 1 unit of cement means 0.23 cubic meters volume of cement. cc 1:3:6 concrete mixture. Meaning of cc 1:3:6 concrete mixture. 1 unit of cement, 3 units of sand, 6 units of 40 mm gravel means a mixture of 33.5% of 20 mm gravel and 66.5% of 40 mm gravel. In 6 units of gravel, 0.31 cubic meters volume gravel of 20 mm, 0.69 cubic meter volume gravel of 40 mm. 3 units of sand means 0.46 cubic meters volume of sand. 1 unit of cement means 0.23 cubic meter volume of cement. cc 1:2:4 concrete mixture. Meaning of cc 1:2:4 concrete mixture. 1 unit of cement, 2 units of sand, 4 units of 40 mm gravel, 4 units of 20 mm gravel means 0.92 cubic meter volume of gravel. 2 units of sand means 0.46 cubic meter volume of sand. 1 unit of cement means 0.23 cubic meter volume of cement. Calculating volume of cement for mixing concrete mixture. cc 1:4:8 concrete mixture means it is a mixture composed of 8 parts of gravel, 1/8 part of cement. 4/8 means 1/2 part of sand, 4 parts of sand mixed with water. 1 cubic meter is 1440 kg of cement. As said earlier, 1 cubic meter 1:4:8 concrete will have 0.92 gravel. In this concrete, 1/8 part will be cement. Hence, 1 cubic meter 1:4:8 concrete will have 0.92 per 8 cubic meter cement. 1 cubic meter is 1440 kg of cement. So, 192/8 into 1440 is 165.6 kgs of cement. 1 cement bag contains 50 kgs of cement. 165.6 kgs of cement is, that's equals to 165.6 divided by 50, that equals to 3.31 bags. So 3.31 bags are required for 1:4:8 concrete mixture. 1:3:6 concrete mixture. 1:3:6 concrete mixture include 6 parts of gravel and 1/6 part of cement. 1 cubic meter 1:3:6 concrete comprises of 0.92 cubic meter of gravel, which means in 1 cubic meter 1:3:6 concrete, sixth part is 0.92 cubic meter, that is 0.92 divided by 6. As discussed earlier, 1 cubic meter is 1440 kg of cement. 0.92 divided by 6 cubic meter cement is, that's equals to 0.92 divided by 6 into 1440, which equals to 220.8 kgs. One cement bag contains 50 kgs of zero point 0.92 divided by 4 into 1440, which equals to 331.2 kgs. That also equals to 331.2 divided by 50, which equals to 6.62 bags. So 6.62 bags are required for 1:2:4 concrete mixture. Method of construction of check dam. Now let us see in depth the foundations to be dug for check dam. Dig foundations for upstream side cut-off wall at the center of A1, A2, B2, B1 with a depth of 0.90 meters and deposit the soil away from stream bunds. Dig at the center of B1, B2, C2, C1 with a depth of 1 foot or 0.30 meters depth and deposit the excavated soil away. Dig at the center of C1, C2, D2, D1 as per solid apron design and deposit the excavated soil away. Mark at 0.15 meters around B1, B3, B7, B5, B2, B4, B8, B6 with lime powder. Dig on both sides of the stream from top up to foundation levels of the body wall at 0.90 meters and deposit the excavated soil away. At the center of D1, D2, E2, E1, dig foundations for downstream side cut-off wall with 0.30 meters width from top of the stream at 1.20 meters depth and deposit the soil away. Dig at the center of E1, E2, F2, F1 from the bottom of the stream with a depth of 0.30 meters and deposit the soil away. Mark at 0.15 meter on both sides of D1, D3, G3, G1, F1, F2, G2, G1, G2, G4, D4, D2 with lime powder. Dig foundations with 0.90 width from the bottom levels of the stream at 0.90 meters depth and deposit the excavated soil away. At the center of B3, B9, D3, D1, B4, B10, D4, D2 with 0.60 meters width from top of the stream up to foundation levels of body wall. Dig foundation and deposit the excavated soil away. The required 40 ml gravel and 20 ml gravel should be brought to the place of construction of check dam. The required implements like concrete miller, water drums, iron baskets, concrete vibrator or rammer should be brought to the place of work. It should be established how many baskets of cement is in one bag. Construction procedure for check dam. After mixing the concrete mixture as per the above procedure, apply 1:4:8 concrete at the center of A1, A2, B2, B1, which shows upstream side cut-off wall, and consolidate it with a rammer. Likewise, apply 1:4:8 concrete at the center of D1, D2, E1, E2, which shows downstream side cut-off wall. Likewise, apply 1:4:8 concrete at the center of foundation of body wall, that is B1, B2, C2, C1, and consolidate it with a rammer. Apply 1:4:6 concrete at the center of foundation of core wall, that is B1, B3, B7, B5, B2, B4, B8, B6, and consolidate it with a rammer. Apply 1:4:8 concrete at the center of foundation of solid apron, that is C1, C2, D2, D1, and consolidate it with a rammer. Apply 1:4:8 concrete mixture at the center of foundations of guide wall, that is D1, D3, G3, G1, D2, D4, G4, G2, and consolidate it with a rammer. Apply 1:4:8 concrete mixture at the center of foundation of toe wall, that is F1, F2, G2, G1, and consolidate it with a rammer. Apply concrete at the center of B3, B9, D3, D1, B4, B10, D4, D2, and consolidate it with a rammer. Form the very next day after the concrete is applied. Curing must be done so that it won't get dried out. Take the centering plates and make it vertically straight on B1, B2 line and second plate on C1, C2 line. Keeping the centering plates of C1, C2 line in such a way it meets B3, B4 line. After looking plates, deposit 1:3:6 concrete mixture at the center and consolidate it with a vibrator or a rammer and complete construction of body wall. Core walls on both sides of body wall, that is, deposit 1:3:6 concrete mixture at the center portion of B1, B3, B7, B5, B2, B4, B6, B8, and consolidate it with a vibrator or rammer and construct up to a height of the stream or with a width of 0.60 meters on all the three sides. Place 1:3:6 concrete mixture at the center of D1, D3, G3, G1, G2, G4, D4, D2, B3, B9, B3, B4, B10, D4, D2 and consolidate it with a vibrator or a rammer, and it should be constructed up to a height of stream towards body wall. Under the body wall with 0.90 meters height and 0.60 meters width. Construct water cushion wall by depositing CC 1:3:6 at the center of D1, D2, E2, E1, which shows downstream cutoff wall with 0.30 meters width and up to a height of 0.30 meters. The center portion of F1, F2, G2, G1 which shows toe wall and E1, E2, F2, F1 which shows loose apron construct on all the three sides with 1:3:6 concrete mixture with 0.6 meters. At the center of C1, C2, D2, D1 which shows solid apron, deposit 1:2:4 concrete mixture with 0.10 meters thickness. Deposit 1:2:4 concrete mixture on top of body wall with 0.10 meters thickness. Fill the center place of F1, F2, G2, G1 with 225 mm thickness stones which shows toe wall and at the center portion of downstream cutoff wall, and construct loose apron. Fill the gaps between the stones in loose apron with gravel to see that there are no gaps. Water curing must be done to all concrete parts for 21 days to maintain moisture. Restoration of check dam. Continuous supervision is required even after constructing the check dam. Because check dam is a cement construction, in due course of time, it is a common phenomenon that cracks may develop in the walls of check dam due to flow velocity, cracks in apron, cracks in body wall on both sides of main walls, that is, upstream side wall and downstream side wall. Moreover, there may be leakages even at the joints between body wall and guide walls. Hence, the damaged portion must be identified. When there are small cracks, joints between body wall and guide wall must be removed completely. If the plastering is done without removing completely, cement may not stick in the cracks and leakage may develop again within a few days. After removing, clean it with water. Plastering must be done with 1:4 mix mortar at the cleaned place. 1:4 mixed mortar is a mixture of 1 unit of cement and 4 units of sand mixed well with water. The mixture should be mixed thick rather than watery. Then apply the mixture inside the cracks. In case there are heavy leakages or cracks, repairing must be taken up on the main wall or body wall. Repairing process must also be taken up if there are any leakages on both sides of the wall of surplus wear. If the concrete apron is damaged or cracks are developed, remove the portion and clean it with water. After cleaning, apply concrete mixture of 1:4:8 cement and sand with required thickness. 1:4:8 concrete mixture is 1 unit of cement, 4 units of sand and 8 units of gravel mixed well with water. Apply this mixture on apron with required thickness. After applying 1:4:8 cement and concrete mixture on top of apron, wearing coat must be done with 1:2:4 cement and concrete mixture. This is generally done with 0.10 meters thickness. Trees must be removed from the lower and upper area of check dam because cracks may develop in check dam due to the roots of trees. This way, trees must be removed from the lower and upper area. Remove silt from behind the check dam and deposit it on the bunds that are on both sides of the dam. This silt can be removed to crop farms to increase fertility to attain high yields. While removing silt from place of water catchment area, remove it 1 meter away from the end of upstream side wall. If it is removed close to the wall, walls of check dam get damaged. Precautions to be taken while constructing check dam. Check wall should not be constructed where there are curves. If constructed, flow velocity is very high at curvy places and the main wall of check wall may get damaged. Velocity of run of water is very high at broad streams. At the same time, bunds may get eroded quickly. Therefore, check dam should not be constructed at broad streams. Check dam should be constructed at narrow streams only. Check wall should be constructed where there are no curves. Check dam should be constructed where width of the stream is big. Check dam is constructed where width of the stream is less. Check dam should not be constructed if depth of streams is less than 1.75 meters. Depth of streams should be at least 1.75 meters for the construction of check dam. Check dam should not be constructed at places where slope of water catchment area is above 2%, because if slope is high, flow velocity will be more and check dam may get damaged. There is no chance of storing the water here. It should be constructed at places where slope of water catchment area is from 1 to 2%. Upstream side cutoff depth should not be less than 0.90 meters. It is to prevent water leakage under the body wall when the flow velocity is very high. Upstream side cutoff depth should be 0.90 meters. Downstream cutoff depth should not be less than 0.90 meters. It is to prevent water leakage at the foundation of solid apron. Downstream side cutoff depth should be 1.20 meters. Soil-related work should not be done in phases. That is, doing some work today and remaining the next day. All the work with soil should be completed at a time. All cement work should be done at a time. Cement work should not be done phases. Cement, sand and gravel should not be mixed with spades because mixture may not blend properly. Concrete mixture should be used to mix cement, sand and gravel. If the body wall is constructed without core wall, soil in the banks may slide off due to the velocity of runoff water, and the body wall may get damaged. Core wall should penetrate at least 3 meters into the embankments. The core wall should be constructed in such a way that it should penetrate into the embankment. Stones used in talus should not be less than 300 mm size. Stones used in talus should be above 300 mm size. Bed concrete should not be poured in foundations without consolidating it. This is because if it is not consolidated while placing concrete at foundations, blowholes may develop inside, which will lead to water leakages as well as foundation may not be strong enough. When bed concrete is poured in foundations, it should be consolidated with a rammer. The end height of bottom wing wall should not be more than body wall's height. The end height of bottom wing wall should be equal to body wall's height. Depth of upstream side cutoff wall should not be more than the depth of downstream side cutoff. Depth of upstream side cutoff wall should be less than the depth of downstream side cutoff. The excavated soil should not be deposited at stream's flow direction. The excavated soil should be deposited on stream's embankments. Body wall of check dam should not be constructed without freeboard. This is because if there is a freeboard, it prevents soil on top of the body wall from sliding off due to velocity of run-off water, and check dam will not get damaged. Freeboard should be kept between 0.30 meters to 0.60 meters. Sand percentage in mix mortar should be 4 units only. It should not be less or more. 1:4 mix mortar should be used in plastering the cracks. 1:4 mix mortar should not be mixed watery. 1:4 mix mortar, which is used in plastering, should be mixed firmly. Concrete mixture of less or more than 1:4:8 should not be used in covering cracks in apron. 1:4:8 cement, sand and gravel concrete mixture should be used in covering cracks in apron. Check dam should be constructed without first removing trees at upper and lower side of check dam. If we construct without removing the trees, roots of trees may penetrate the walls of check dam and check dam may get damaged. Trees at the upper and lower side of check dam should be removed. Silt should be removed near wing wall. Silt must be removed at least 1 meter away from the end of wing wall. Conclusion.
Now you have thoroughly understood the following.
What is a check dam? Benefits of check dam. Suitable location for constructing check dam. Main parts and operating method of check dam. Marking procedure for the construction of check dam. Construction procedure for check dam. Precautionary measures to be taken while constructing check dam. Restoring check dam.